And during this whole session, I have already told you, like, when we'll cover this integral calculus, because we have to cover two more chapters. One is area bounded by curves, and second is differential equations. So, while covering this, if you have any doubt regarding integration or differentiation, please don't hesitate. All of this section, like differentiation and integration, is belong to calculus, and they are almost same. Fatima, so we were solving questions on properties of definite integration. We have covered the whole chapter and we have solved around 15 questions from the chapter. So we covered the miscellaneous exercise and some of the important questions from definite integration. Just watch that class and don't go for the solution directly. You can try these questions first. After that, if you have any problems, so you can watch the video. So we have covered we have covered all of the integration part. And we will be, we'll be repeating this part again because in both of the chapters, we'll be covering integration only. So whatever you have learned, you'll have to apply that. Okay. Cool. Then in that case, we'll start with our next chapter. So we call this unit as integral calculus. And whatever we are, the next two chapters will be known as like application of integrals. How do we apply these integration? We have covered a lot of formula in integration. Why did we took so much pain? That we need to understand. So application of integral consists of two chapters. There are a lot of application, first of all, not just two chapters. But in your syllabus, you'll be covering these two parts. One is area bounded by curves or area between curves. And second is differential equations. We'll cover differential equations later on. Today we'll start with area bounded by curves. So let me give you an introduction about the chapter. Like, what are we looking for? Area bounded by curves basically tells you the area related to irregular figures. Now, what do I mean by irregular? You already know a lot of formulae for area related to your square, either 2D figure, square, rectangle, and the rhombus, parallelogram, triangle, right? And then there are a lot of 3D figures as well. So 3D figures, we basically covered cylinder, cone, hemisphere, sphere, frustum of cone, in fact, cube, cuboid, right? So all of these type of figures, which are commonly used, which will be frequently used, we have already covered all of them in the previous classes, or either 10, 9 to 10. So now we do have a lot of surfaces, right? A lot of irregular shapes as well. I get it that these circle or ellipse or parabola or hemisphere, sphere, circular, cone, cylindrical, these shapes are frequently used, right? Like you'll be occurring, the occurrence of these type of shapes will be a lot more than that if we talk about this kind of figure or this kind of figure, right? So these are irregular shapes, but they do exist, right? We need to cover the area. We need to find the area of these type of figures as well. Let's say you are designing, there are a lot of things which are not regular in shape, right? So while designing these shapes, you need to find out the area of these shapes. So the point is, like, first, my question is, how did we even find out this area? Let's say area of rectangle is length into breadth. But how did we come to that point? And the answer to that question is integration. Every area, whatever formula you have, every area is derived by using, derived by using integration. Either it is indefinite or definite, that's a different point of view for now. But every formula is derived using integration. So if we can derive these formulae, so we can obviously derive these irregular shapes formulae as well. We don't need to derive them because we will not be facing them frequently, but rather we should have we should have an approach how to solve these type of questions. So how to find out the area between any figure, be it square, be it rectangular, be it circular, or be it anything. So a very fine application of integration has been applied to area. Now, how are we defining this area is, let's understand it from a very basic concept. So just for a minute, forget this whole figure. This is a rectangle, we know that, but for a minute, let's leave this. Let's focus on this small part. So you must know how to take an element. You have covered that in, maybe in your physics classes. And you have covered like a lot of formulae related to electrostatistics, electrostats and magnetism and mechanics as well in class 11. So you have derived a lot of formula using integration. We've already done that. But how does that concept occur? Just we can just talk about that. So what we do is we take a very small part of this whole big rectangle and we try to find out this area. So what is happening here? Let's say this is length. And let's say this length is x, right? This whole length. And let's say this is your breadth. Breadth is equal to y. And we want to cover the whole area of this rectangle using this length and breadth. So what we are doing is, we first of all, let's talk about the dimension. So we have already seen that the unit of area is either meter square or centimeter square or something like that, or maybe kilometer square or maybe mile square, whatever, but it always exists in the form of meter square, centimeter square, square. Square is common to everyone, right? So how did this come? If we talk about meter square is nothing but meter into meter. So some distance gets multiplied with another distance to find out the area. So the basic foundation of area is distance into distance. We need to multiply a distance with another distance to find out the area. Now these distances can be anything. They will change for different shapes. They will change. But area, the concept of area will always remain the same, that we need to multiply a distance with another distance to find out the area. Just similarly, if you want to find out the volume, then it is always in meter cube, centimeter cube. What does that mean? Basically, you are multiplying three distances. So one distance 1, let's call it D1, another distance D2, and third distance D3. You have to multiply three distances to find out the volume of any figure. I'm not talking about just regular figures. Yeah, in case of regular figures, you will be able to find out these distances very easily. Let's say for cuboid, I already have these three distances. How? One is length, one is breadth, and one is height. So we have all the three distances. In case of cube, all the three distances became same, right? All the three sides are same, because whatever your length is, your breadth will be the same and your height will be same for that cube. If you're calling that surface cube, then height, breadth, and length has to be same, right? So all of the distances become A. So that is how you calculate area and volume. So if you want to calculate this area, right, so you have this small length, which you call as dx, and you have this breadth, which is Why? So if I want to, if I just want to find out the area of this strip, small, very small strip, you also know this structure as element. This process is known as taking element, right? So this element, the area of this element will be something like this, y into dx, right? Now what you are doing now, you're taking this dx, right? Right now the value of dx is near about 0. This is a very small strip, right? But if you take these strips, if you take these multiple strips, in fact, almost infinite strip to cover out the whole area, right? Let's say you take this strip, you repeat these strips multiple times to cover the whole rectangle, right? If you do that infinite times, at some point of time, you will cover this whole rectangle, and the area will be defined as y into dx in plus y into dx plus y into dx plus y into dx up to infinite times, right? And that can be written as, because integration, right? Also know the word of integration. Integration is nothing but summation. So the basic nature of integration is to sum out a lot of things. And the basic nature of differentiation is to break a big function into smaller function. You can also understand that using formula. If you differentiate x square, you get 2x, right? So you had x square before, which becomes 2x now, right? So this is basically breaking out a bigger function into smaller function, which is known as differentiation. So differentiation is nothing but breaking out a big piece to small pieces. This is differentiating this whole thing. And integration is nothing but summing out all of these small pieces to make a big piece, right? So integration is nothing but summation. So whenever you're talking about summation, in fact, you can change summation to integration. This is the symbol sigma used for summation. Sigma is used for summation. So if you want to find out the sum of a lot of terms, maybe 10 terms, 15 terms, 20 terms. So generally what you do is you use sigma to show that sum. But you can always change that sigma to integration, because integration and summation are similar things. Right? So if you want to find out the sum of this rectangle, you can find that out, y into dx. Now, how do you define what is the length of dx? You have to take this point as 0, and you have to take this length as x. So on number line, if you go from this point to this point, how much distance you are covering? So if you consider that as 0, then this distance will be x, right? To show that, you can use 0 to x, sorry, here, 0 to x. And that is how the formula of area of rectangle became. If you figure that out, if you solve that, you will get x into y, which is nothing but length into breadth, which is the formula for area of rectangle. So to find out the area, this is a very basic concept. To find out the area, you take one element. In fact, to find out the volume, you have to repeat the same procedure. So either to find out the area or to volume, you have to select an element and then find out, then integrate that element over the whole thing, either length or height, or it can be anything. Now the procedure to take element is different for 2D and for 3D. So we are not going into detail in that portion. But yeah, that is how it is happening. Practically, this is happening. If you talk about integration, like how we are applying integration in finding out the area. So that is how we solve the questions of area using integration. So this is a very basic idea. You don't need to go much about it, but that's how we are dealing. Now talking about what do we have to do in this chapter? Objectively, how would we face a question? How will be the questions? and how to solve them. So there will be two type of questions. We'll be covering the basic type today. Yeah, guys, can I remove this? If someone is writing, please raise your hand so that I get to know. Okay. Guys, just a minute. Yeah, sorry. Yes, so the very basic concept first. Let's talk about the basic concept related to area between curves. So this is a very basic one which we are going to discuss, like how to integrate area. I mean, how to find out the area. So you will be given a question, something, you'll be given a function actually, and you'll be asked to find out the area of that function. So let me give you an idea about the question and the area enclosed by the circle. Yeah, so you can come on page number 361 in your NCRT. There will be a question, example one, find the area enclosed by the circle. And then example two is also find the area enclosed by ellipse. So you will be seeing a lot of question about the same. Yeah, so question will be like, you will be given a function and you will be asked to find out the area either enclosed between them or something along this line. Right? So a very basic concept is, let's say I'm given a function. Let me write the heading first. To find the area under any curve. First is this very basic concept. So what we are saying is, let's say you give us one function. Yeah, by the way, guys, I'm really sorry I did not tell you this before. You need to be good with graphs. Graphs are important for this chapter. You need to know how to draw the graph of any function. I'll be telling you whenever required. I'll tell you some of the things irrespective of the questions. I'll tell you how to draw these graphs, like some basic graphs of circle, ellipse, parabola, all of them, and straight line. So 4 things I'll tell you before starting these things. Okay. But there will be some figures. Yeah, also modulus of x, mod x. You need to know the graph of mod x. We have already discussed the graph of mod x though in the class. So just revise them. Okay. But you'll be getting, I guess, 2 or 3 difficult functions as well, in which you need to know how to draw a graph. So I'll tell you a lot. I'll tell you, I mean, 2 or 3 things about the graph as well. What to focus on and how can you draw a graph. Obviously, the graph should be rough. You'll not be able to make the exact graph. But yeah, you should know. Okay? I mean, you should know the idea. So to find the area under any curve, so you'll be given a function. Let's say the function is y is equals to fx. This can be anything, maybe x square, maybe sine x or cos x. And similarly, x plus x square or x square plus y square is equals to a square, something along the line. Right? Let's say my function is y is equals to fx, and this looks like this. This is the graph of this function. So the first thing, I'm writing the approach this side. The first thing we need to focus on is graph. If you're not able to solve for graph, I don't think we'll be able to solve the question properly. And as soon as we draw the correct graph, we'll like 100%, 50% work is done. So first is draw the graph of given function. So let's say we have the graph of y is equals to fx, and this looks like this. Now, in the question, we will be given what area we need to find. There will be a lot of area coming under this curve. Right? Now, coming under this curve, what does we mean by area under any curve? Area under any curve is basically the area that lies below this curve up to axis. Up to axis. Either below the curve or above the curve. Can be anything, but up to axis. So if I want to find out this area up to axis, just remember that. I can find that out. Very easy. Now this area, if you draw this function, this will be, if this is a continuous function, this will be endless, right? This can be, this can be extended to both sides. The function can be extended to both sides, right? So there will be a lot of area. You need not to find out the whole area. You just need to find out some specific area. So for that specific area, you will always be given that some limits. Like you will be told that find out the area under y is equals to fx from x is equals to a to x is equals to b. Something like that. From x is equals to a to x is equals to b. This is the area you need to find out. And to find that area out, you just need to integrate this function. So the area, the answer of this is area is equals to fx dx, the integration of this function from a to b. Fx dx from a to b. Guys, don't write fx. First write y into dx. See, I told you the first example in which we were trying to find out the area of a rectangle, right? And what was the area? Length into breadth. So distance into distance. First distance was y and second distance was dx. The area remains same. Either it's y into dx, or you could have also take the element like this. Like this. If you would have taken this, in that case, the breadth would have been dy and the length would have been x. So that area which you calculated can either be written as x into dy or y into dx. You can find out the area using any of the formula, either x into dy or y into dx. Something with the limits, obviously. These limits can be anything. But the basic formula to calculate are these two, either x into dy or y into dx. So to find out this area as well, what I can do is I can integrate this y, which is nothing but fx. So integrate this function fx from a to b to find out the area. This is the very basic structure. So either you will be given a formula in the form of, you will be given a function in the form of y is equals to fx or x is equals to fy. It can be it can be in any form, but either it is y is equals to fx, that is y will be given in terms of x, or x will be given in terms of y. It can be anything. So if y is equals to fx is function given, for example, y is equals to sine x, or y is equals to sine x plus x squared. So this is a difficult function to draw. You won't be able to draw it directly. So y is equals to sine x, y is equals to x square, y is equals to mod x. It can be anything like that, right? So if the function is given in this form, you would need to calculate the area using this formula. You'll be given with a, value of a, value of b, and fx. All of these things would be given, right? Now, how to identify that, we will discuss that a little later. But yeah, that's the approach, right? So first, draw the graph, right? And then integrate. Second thing is integrate y is equals to fx, or sorry, let's take y is equals to fx wala case only. So integrate y is equals to fx within given limits. So area would be fx dx from a to b. Now this function can also be given as x is equals to fy, but that is nothing different. We will discuss that as well. Now let's solve a question based on this. You guys please write it. Yes, can I remove this? If someone hasn't written, just raise your hand. Cool. Okay, so before solving, let's discuss some basic graphs. You need to know these graphs. Okay, so first is straight line. Straight line is generally defined as y is equals to mx plus c. This c, you know, is known as intercept. Intercept on y-axis. And this m is known as slope. Okay. Y is equals to mx plus c will be something, or also you can draw the graph of straight line using that boxes wala concept, which you have already covered in 10th class and 9th class. So let's solve one question. You will be good to go after this question. So let's draw the graph of x plus y is equals to 4. So you have to approach. I would say just put one time x0. If you put x0, you will get y is equals to 4. Y is equals to 4 would be something here. Yeah, this point. So one point is this. Find out 2 points. In case of the graph, first of all, the graph function will always be linear. If you're talking about straight lines, you'll always encounter linear function only. Linear functions will give you a graph of straight line. So you can check that we have a linear function here, x plus y is equals to 4. To draw this graph, whatever graph linear, whatever linear equation you have been given, to draw the graph of a linear equation, just find out 2 points, okay, and join them. So first point is 0, 4. If I put x 0, I get y as 4. If I put y as 0, I'll get x as 4. So x4 money, this point, right? Now you can easily join them and you'll get the graph of x plus y is equals to 4. So to draw the graph of a straight line, I would say just find out 2 points and join them. And the graph of straight line will be the graph of a linear function. So whenever you encounter a linear function, just remember the graph will always be a straight line and you just need to find out 2 points. So this is the easiest graph. You should also write these points. This is 4, 0 and this is 0, 4. Now let's first of all, let's extend this question to area. Okay. Now we need to find out another question is given. Find out the area. Let's write this question as find out the area bounded by x plus y is equals to 4, x greater than 0 and y greater than 0. So first of all, understand the question. What the question is, what does the question wants to find? So the question says that you need to find out the area bounded by this line, which you have already drawn. This is x plus y is equals to 4. Then x greater than 0. Now when will x be greater than 0? Can you guys tell me what are the portion here on this graph which suggests that x is greater than 0? Also, you can think about in terms of quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. So which quadrants will give you x greater than 0? The question is this. In first quadrant, is x greater than 0? Is x positive in first quadrant?
Yes, sir.
Right. And in second, third quadrant, x is negative. So, and again, in fourth quadrant, x is positive. So if I talk about x greater than 0, I can easily check that first and fourth quadrant are the quadrants in which x is greater than 0. And first and second quadrant are the quadrants in which y is greater than 0. What do we need? We need x greater than 0 and y greater than 0. So basically, what do we need is, I'm writing this x greater than equal to 0 and y greater than equal to 0. That does not change anything. Don't worry about that. So if this x is also greater than equal to 0 and y is also greater than equal to 0, so that means we are talking about first quadrant, right? Now we want to find out the area which is in first quadrant and which lies under this line, x plus y grid is equals to 4. Either you take that explanation, either you understand it like this, or x plus y is equals to 4 is this line. Now x greater than equal to 0, when we say x greater than equal to 0, we are just talking about this line, only this line. And y greater than equal to 0, so only this line. This whole line represents y greater than equal to 0. Right? Y greater than equal to 0 is this line. So if you are told to find out the area bounded by these three lines, then the area bounded by these three lines is certainly this area. We're talking about this here. Now, to find out any area using integration, any area, to solve any question related to area bounded by curves, you need to find out a function under which the area has to be calculated. For example, what I'm trying to say is, in this case, this whole area lies under this line. If you are able to spot that function under which the whole area is lying, I'm not saying even whole. Sometimes you will have to use two functions to find out the area. But you can only find out the area under any other curve or above any curve as well, but not side. I mean, you can't take this side or you can't find out this area. No, you can only find out the area under any curve. So if I want to find out this area, first I will have to spot a function or any graph under which this area is lying. I can easily spot that whatever area I need to find out is that lies under this graph from this point to this point. Let's say this point is A and this point is B. So I want to find out the area under this line from point A to point B. That is the physical significance of what we are going to do mathematically now. So I'm going to write this. Find out the area under the line find out the area under the line from point A to point B. Right? Now we know what is area. Area can be represented by two forms. Either A is equals to y into dx, or area can be x into dy. Now, as we haven't discussed this, so we'll not touch that portion for now. We'll only figure out how to solve this y into dx. So area is y into dx. Now I have a function x plus y is equals to 4. So where does this y come from? This y comes from the same function which we have used. I mean, from this line. This line is, x plus y is equals to 4. So y from here is 4 minus x. So what you need to do is you need to find out the area. You need to integrate this 4 minus x, which is y, obviously. 4 minus x from point A to point B. From point A to point B. Area is equals to this. Now, what do we mean by point A and point B? Point A and point B will basically tell you the limits within which this area has to be calculated. Now, how to find out the limits? To find out the limits, check for your variable here, whether it's written dx or dy. If it's written dx, then you need to consider the x coordinate of these points. So the x coordinate of A is 0 and the x coordinate of B is 4. No, just observe this practically. What you're doing is you're basically integrating this line from x is equals to 0 to x is equals to 4, right? For this function y. So your area would be 4 minus x dx from 0 to 4. Integration of 4 minus x dx from 0 to 4. You can find out the area very easily now. The integration of 4 is 4x minus integration of x is x square by 2 within the limits 0 to 4. So if you put 4, you get 4 16 minus 16 by 2 8. So you get 8. If you put 0, you get 0. So your area is 8 units square. Obviously, you can verify that because you have this triangle. This is a triangle, right? And this triangle, you have the height of this triangle and you have the base of this triangle. Base is also 4, height is also 4. So area will be half base into height, which would be 8. You could have find this out very easily. I'm not denying that. But this is just a basic concept. This is just first question. So I wanted to find out an area which you can also verify. You can easily verify that the area is 8 unit square. And we find that out using integration as well. So while integrating, use the formula y into dx, right? Y into dx. If it's dx, then limit has to be for x. If it's dy, then limit has to be for y. This is a basic concept which we have already encountered this concept in definite integration. Whatever your dx or dy, whatever you use the variable, the limit is for that only. Okay, I have a question for you. Solve this. Wait. Can I remove this? Okay. Now try to solve this. So the question is, find out the area under curve 2x minus y is equals to 1 from x is equals to 1 to x is equals to 3. Now in this question, I have already simplified the question for you guys because I have given the limits directly, right? You need to integrate this function from x is equals to 1 to x is equals to 3. From x is equals to 1 to x is equals to 3. So the limits are already set. But before solving this question, the first thing you should do is to draw this graph. Draw this graph and after that we'll start the question. I mean, you guys have to start the question. Nazia and Sakina, you both are in same class?
Yes.
Okay. So do you guys help each other out?
Yes, sir.
Okay, good. I'll be asking the questions. You have to answer that. First, solve the question, then I'll ask some questions. Has anyone of you able to draw the graph? If yes, please tell me 2 points through which your graph is passing.
0, -1, and 3, 2, 3.
0, -1, yeah, correct. And 2, 3. Oh, yeah, correct. So 0, -1. This is always a good idea to put first x0, so y -1. So 1 is this point. And another point is 0 -1. Another point you told is 2, 3. Okay. So 1 is 2, 3. Yeah, 2, 3 is also fun, but I would rather solve y for y is equals to 0. If I put y0, I get x half. So let's say this is 1. So my line will be passing through this point. And this is some point 1, 0. So this is the graph of 2x minus y is equals to 1. We need to find out the area under this curve, which we can find out by integrating it. But we have been told the limits from x is equals to 1 to x is equals to 3. So this is x is equals to 1. Let's say this is x is equals to 3. We need to find out this area. To find out the area under any curve, you just need to integrate it. We have already discussed that. So tell me the area of this shaded portion. This is the area which we are trying to find out. We know to find out area, we need to use this formula y into dx. Let's say this point is A and this point is B. We need to integrate this from A to B. We have discussed what is A, what is B, what is Y. So my next question is, what is the function we need to integrate?
Y is equal to 2x minus 1.
Correct. Y is equals to 2x minus 1. So we need to integrate 2x minus 1 because the value of y from this function can be calculated as if we shift y to right hand side and 1 to left hand side. So we will get 2x minus 1 is equals to y. So say 2x minus 1 is equals to y or y is equals to 2x minus 1, both are same thing, right? So y is equals to 2x minus 1. So this value of y would be 2x minus 1 for this function. Hence, we need to integrate 2x minus 1 from, can you tell me the limits?
1 to 3.
Yeah, correct. 1 to 3. So what's the area? Has anyone of you find out?
6 square units.
Okay. I don't think so. Nazir, check again. Oh yeah, correct. So you put 3, you get 9 minus 3, 6. You put 1, you get 1 minus 1, 0. The answer is 6 square units. So area can be easily calculated. If if we have area under any curve. And if we know how to draw that curve, that is a very important point. So the concept of area is easy, first of all. It's not like this is a very fancy thing and you would not be able to solve it. The concept of area is easy. What is difficult is to draw the graph. So I was about to start the graphs of certain functions, but then I thought let's check this out first. What is the concept? How to find out the area? Now let's say if I change this curve from 2x minus y is equals to 1 to some other equation, the whole point is to draw the graph. If you're not able to draw the graph, you will not be able to solve for area. You know what to integrate, how to integrate everything, but you won't be able to solve it because you are not able to find out the area. I mean, you're not able to find out you're not able to draw the graph. Now let's understand first how to draw some other graphs. These are popular graphs. Some of them some of them are known to you. Can I remove this? If somebody is writing, please just raise your hand. Okay. So first graph was straight line. Now second graph would be modulus. Second is modulus function. We have already talked about modulus function. So modulus function is y is equals to mod x, right? Now mod x can be written as either x or minus x, depending on the value of x. If x is positive, this will come out as it is. If x is negative, we would open this using minus x, the minus of the part inside it. And the graph of this function is V-shaped graph. Something like this. It's the graph of y is equals to mod x. This angle is 45 degrees by the way, because this line is y is equals to x, this line, and this is y is equals to minus x. So this is the graph of y is equals to mod x. This angle is also 45 degrees. Third type of function is parabola. Now first we covered a linear function, straight line. Second we covered modulus. Now third is parabola. So the first task is how to understand what a parabola is. How do we know the graph is a parabola? This is a very basic, I will tell you a basic shortcut for all of them. So while any function or any equation represents parabola, this will only happen if one variable is in quadratic form and if other variable is in linear form. For example, let's take this, a very basic graph in this, y is equals to x square. This is certainly a parabola. Now, how am I so certain about this is because there is a function, there is a variable x, which is in quadratic form, x square. And there is another variable y, which is in linear form. So any equation which has one variable in quadratic form and other in linear form can always be drawn into a parabola. The graph will always be a parabola. Now, what type of parabola, what kind of parabola? There are so many graphs of parabola. I mean, the shape will be same, but the orientation will differ. I mean, if I draw a graph, I mean 2D structure, so the parabola can be anywhere. These are U-shaped graph, basically. These are all parabolas. Parabola can be anywhere. There are different parabolas which can be drawn in this graph. What we need to know is which type of parabola, I mean, how to draw this exact parabola. So to draw parabola, you just need 2-3 things. First of all, just learn the graph of y is equals to x square. In most of the cases, you will only encounter these two equations, either y is equals to x square or x is equals to y square. So y is equals to x square is this curve. This is y is equals to x square. This is not scaled. I'm not good with drawing. But if something like this, this is y is equals to x square. Just a minute, give me a minute. Yes. So y is equals to x square is something like this. Now, in most of the cases, you will be given this graph of y is equals to x square only. But in some cases, they will change this function like this. Let's understand this as well. So what they will do is they'll add one constant either to the left hand side or to the right hand side. Well, let's talk about this. So this point 0, 0 is known as the vertex of parabola. Vertex is basically the point about which the graph is symmetrical. If you take the right hand side of this vertex, that will exactly be the mirror image of left hand side. So if you put a mirror, let's say this y-axis is a mirror, they both are identical shapes. This is a mirror image of this part, right? So vertex is that point of a parabola. So let's say I need to draw y is equals to x square plus 1. How to draw that graph? Now you know that this satisfies 0, 0. If you put x 0, you will get y as 0. Right? But if you put x as 0 in this case, you get y is equals to 1. So this is nothing but the same graph, just one point above the graph. Same graph, just one unit above this graph, y is equals to x square. So if you need to draw x square minus 2, you just need to know the graph of y is equals to x square. No, let's say x square minus 4. So this is nothing but if you put x 0, you get y minus 4. So this shifted to 4 units below the graph of y is equals to x square. This is nothing but below the graph of x square. So at max, you would be given these kind of questions, right? So if you know y is equals to x square, you can draw any graph which contains y is equals to x square plus some constant. That constant can be negative, that can be positive, or anything. Y is equals to x square plus 1. This is y is equals to x square minus 4. So just know the graph of y is equals to x square, you'd be good to go with all these kind of graphs. Now B part. So first function is y is equals to x square. That is y was linear and x was quadratic. Now if x is linear and y is quadratic, nothing, the same function. It would be just rightwards. So this would be something like this. This is x is equals to y square. Now, if you are given x is equals to y square plus 1, just simply check, put y 0, you would get x1. So if x is equals to y square plus 1, this would be the graph. The vertex would be this point, 1, 0. And similarly, if you need to draw these kind of graphs, this would be x is equals to y square minus some constant. Let's say this is 2. So this point will be minus 2, 0. And this point will be 1, 0. So just know the graph of x is equals to y square. You'll be good to go for all of these kind of functions in which x is linear and y is quadratic. These are two very basic graphs of parabola. Nothing fancy. Sometimes we may be given like some difficult graph as well. When that portion will come, we'll change the graph. I mean, I'll tell you how to solve that as well. But just know these basic graphs. Because most of the times, 95%, 99% questions will be given on these points. This is a parabola, which is a U-shaped type of graph. X is equals to y square is rightward parabola, and this is an upward parabola. If the question is something like y is equals to minus x square, the parabola shape remains same, right? Vertex remains same. It is just the downward parabola. So if y is equals to minus x square, this is the graph for y is equals to minus x square. This is known as downward parabola. And let's say if x is equals to minus y square, then the leftward parabola will come into the picture. Now the next is two more parts. One is circle, graph of a circle, and another is ellipse. Also, you need to revise this chapter, guys, conic section. So just read the basic fundamentals from conic section for the next class, for the next Saturday. I'll tell you whatever the things are. I mean, there will be some technical terms used like latus rectum, vertex, focus. So I just want you to go through it. I'm not saying that remember all the formulae. I'll tell you the formulae which we'll use. Let's just go through it. Okay. Before coming to the next class. Can I remove this? Okay. So the fourth type of graph is circle. There are so many equations of circle, but I'll only tell you the basic equation for now. The basic equation is x square plus y square is equals to a square. In this case, center is origin and radius is a. X square plus y square is equals to a square. So let's say this is 2D. So this will be a graph something like this. These kind of things. This will be your origin. Let's say this graph is, this point is 3. So in that case, the radius is 3 So this will be x square plus y square is equals to 9. Let's say this point is 2. So the graph will be of x square plus y square is equals to 4. Right? This is the simplest form of circle in which the center is origin and you will be given some radius a. In this case, the radius is 3. Similarly, in this case, the radius is 2. Now, one complex equation for circle is, this is the complete equation actually. So another complex equation for circle is x square plus y square plus 2gx plus 2fy plus c is equals to 0. Yeah, before that, how to identify that the given equation represents circle? So we understood the rule for parabola. One variable will be in linear form and another will be in quadratic form, right? So in circle, both x square and y square will be present. This is the shortcut. This is to know when the given equation is representing circle. So if the given equation represents circle, both x square and y square will be given and the coefficient has to say. So whenever you encounter any equation in which both x square and y square are present and their coefficient is same, it can be anything. For example, in this C, in this the coefficient is 1 for both of them. In this the coefficient is 1. The coefficient can be anything. I'm not saying that the coefficient has to be 1. Coefficient can be anything, but has to be same for both of x square and y square. So if you see x square, y square, the coefficient is same, then you know this equation represents circle. Now, there can be a part of x as well and y as well. If this x and y wala part is given, then the equation is complex. If this x and y wala part is not there, then the equation is simple. Right? As in this case, first case. Only x square and y square, the equation was simple. But if x square, y square, and along with x and y, then the equation is complex. So in these cases, the center is minus g comma minus f. And your radius will be g square plus f square minus c. Root over g square plus f square minus c. Let's take an example to understand that better. So let's draw the graph of x square plus y square plus x minus 8 is equals to 0. Let's take this 2x. Yeah, correct. Okay, so x square plus y square plus 2x minus 8 is equals to 0. Now, how to identify what is, you need to identify g, f, and c. To find out g, you can compare this x wala term 2gx with 2x. So the coefficient of x is 2g here, while the coefficient of x is 2 here. So 2g is equals to 2. Then 2f is equals to, can you guys tell me the value of 2f in this case?
0.
0, correct. Because there is no term containing y. There is y square, but we don't care about y square for this f part. We need to find out a term which is containing y. As there is no term, so this 2f wala part has to be 0, right? And this c is minus 8. So this g is 1, f is 0, and c is minus 8. So you can say that center is minus g comma minus f, that is minus 1 comma 0, and radius is g square, which is 1, f square, which is 0, minus c. So 1 minus minus 8, which is 9, and hence the radius is 3. Right? Now to draw this graph, I'm removing this. Guys, have you written this? This left side one part. Okay. Now to draw this graph, you know the center is minus 1, comma 0. The center is somewhere this, and the radius is 3. Now, as the radius is 3, this is the center. The radius 3 would be something. I mean, the circle should pass from these points. Now, the graph will be similar to this. This is minus 1, comma 0. This is 2, comma 0. The distance is 3, remember. And this should be minus 4, comma 0. So the graph of x square plus y square plus 2x minus 8 will be something like this. Right? Now we can find out. We'll talk that about later. So these are two types of circle which you need to know. Can I proceed? Okay. So the last figure, not last, actually this should be second last, but you would not encounter hyperbola a lot. Only 1 or 2 questions will be given on hyperbola. So I'll tell you that as well. So the second last figure is ellipse. Now, how to identify whether a given equation represents ellipse or not? Both x square and y square will be present. Both will be present, but their coefficient is not same. Let's say the coefficient of x square is 1. In that case, coefficient of y square would not be 1. Definitely not be 1. So in these cases, the equation represents ellipse. Though they have same sign. What do I mean by this? So first of all, see what kind of an equation we'll be getting in ellipse. So let's say this is an equation given to me. X square plus y square is equals to 9. See, there is x square, there is y square, right? So we know either this can be a circle or ellipse or hyperbola. Can be anything, right? But if the coefficients are same, then it has to be circle. If the coefficient of x square and y square are same, then it would be circle. If they are not same, then it could be hyperbola and ellipse. So we can observe that a coefficient of x square and y square are not same here, because the coefficient of x square is 1 by 1, basically 1, and coefficient of y square is 1 by 4, right? So as they are not same, now we need to check what is their sign. This is positive, coefficient of x square is positive, while the coefficient of y square is also positive. So we can check that both x square and y square are present. Right? Both x square and y square are present, but the coefficient is not same. Now the coefficient of x square and y square, both are greater than 0. So both have same sign. Either they both should be present, or I mean positive, or they can be negative. But both has to be same. Then it implies that the given equation represents ellipse. Now, how to draw ellipse? To draw ellipse, you just need two things. So ellipse is nothing but a squeezed figure of circle. Like if we squeeze circle, the figure we will get is ellipse. I'll show you. But first of all, what are the two things you need to find out to draw an ellipse? So in most of the cases, guys, this will be 1, first of all. If it's not 1, in the place of 9, it should be 1. As soon as you encounter, as soon as you figure out that the given equation represents ellipse, try to make your constant term 1. If it is not, you can make it. Like in this case, what I will do is, I'll divide the whole equation by 9. Or rather, I can take this 9 into left-hand side. So it will be x square by 9 plus y square by 36 is equals to 1. Okay. So if you figure, okay, there are two ways basically. One is this, which I'm telling you. One I'll tell you later. Okay. So make this one, right? Make this one. And then see this part. The term which is written below x square. Now, term below x square is 9. Root of 9 is 3 and minus 3. So you got 2 points, minus 3 comma 0 and 3 comma 0 from this 9. Or you can think this, what I'm doing right now is nothing but I put y0. As soon as I put y0, I got x as plus minus 3. Now put x0, you will get y as plus minus 6. So find out these 2 points. So 2 points when y is equals to 0 and 2 points for x is equals to 0. Now these are the points through which your ellipse will pass. So how do you draw your equation? This will not be the correct equation first of all. But yeah, this is an equation of ellipse, something like that.
Sir,
Yeah.
it's 0,6, right?
Sorry, it's 0.6. Correct. This point will be 0.6. This will be 3,0. This will be 0, minus 6. And this will be minus 3,0. This is also the vertex. These two will be focuses. We'll talk that about later. But for now, just know the basic simple things about graphs. So ellipse would be a figure in which both x square and y square will be present. Their coefficient will be same. I mean, their coefficient will have same sign. Either both will be positive or both will be negative, but they won't be the same in value. And if we talk about hyperbola, everything will be same, just their coefficients will have different signs. So their coefficient will not be same and will not be having the same sign as well. So coefficient of x square would be, if coefficient of x square is positive, coefficient of y square has to be negative in case of hyperbola. Yes, can we proceed to the last figure? Okay. So this is a very rare figure. You will not get the questions on hyperbola much. But nevertheless, you need to know about this. So hyperbola, when both x square and y square are present, different signs. When the signs are different, they can never be equal, first of all. If it's 1, then second equation, then second coefficient should be either -1, anything negative, right? So this will be something like this. The general equation, I'm writing out the general equation. X square upon y square minus y square upon b square is equals to 1. And the graph will be something like this. I'm just drawing out the basic graph. No, not this. These are two graphs. This point would be minus a comma 0. At this point would be a comma 0. This is the graph of a hyperbola. So these are some basic figures. You need to focus on 3 things. Parabola. These are important because you will be facing them a lot. Parabola, circle. These are the 2 most important things. And then ellipse as well, because some question will be based on ellipse. So just check out the basic figures, the basic technical terms. I'll tell you all the formula in the class only. So just go through it. Okay. And then we'll start with the area. Now we are we'll be in a good position if we can understand the graphs. So we can finish this whole chapter in 1 class. But if you'll be, if you'll not be good with graphs, then we will have to take 2 classes for this. So it depends on you guys. When are we finishing this chapter? Chalo, we'll talk about it in the next class. Just go through with this portion.